This video will walk you through the steps as to how to apply Cramer's rule in finding the solutions for a 2x2 system. So, you'll notice that the equations we're going to work with in these problems here for Cramer's rule, these look a lot like the systems of equations problems we dealt with earlier in the chapter. You learned how to do graphing, substitution, elimination. This is just simply another strategy in which you can solve for the x and y, the solutions of any given system. So in order to do this, this basically takes your knowledge of how to use determinants and apply them. So in order to do this here, we're solely going to focus on 2x2s, so none of the math will be too complex. You won't have to rearrange tons of numbers, but there is a process to it. So in order to figure out what x and y could be using this Cramer's rule, we have to do a couple of things. So at the top here, you'll notice the way these two systems, these two equations are written out. The values that go with x and y, so the coefficients, they are going to form their own matrix. So we're going to rip off the a, b, c, d, the stuff that's next to x and y. That's going to be its own matrix. The first step we're going to take is finding the determinant of the matrix of these four values. Now, we have to find that so that way we can actually find the solutions for x and y. As long as the determinant is not 0, we can go find solutions. The reason being, if it is 0, notice the formatting to find x and y. We are dividing by whatever the determinant is of this solution. You can't divide by 0. So if you get a determinant of 0, it's a no solution problem. It's not going to work. But you'll see in these problems here, we are going to get some determinant that's not 0, and you'll be able to solve. But at any rate, we're going to go find the determinant first, based on what you learned in the previous lesson. Then we are going to go find x and y. So why don't we start by finding just the determinant of the numbers that are the coefficients of x and y. So you can see here in the first example, we have 6x minus 2y equals negative 16, negative 3x plus 5y equals 16. The first thing I'm going to do is write a matrix that involves these four coefficients right here. So I'm going to go find the determinant of this matrix right here. So again, those four values just come right in order from the four values, the four coefficients with x and y. So I'm going to go ahead, I'm just going to solve this by hand. Keep in mind, you learned in the last video how to check this using your calculator, so you can feel free to check the math using the steps using your graphing calculator. But again, to find the determinant, start with your top left diagonal, multiply those values. 6 times 5, subtract away the product of the two values in the top right diagonal, going the other direction. So it'll be negative 2 times negative 3. Quick amount of PEMDAS, you get 30 minus 6, which equals 24. Be very careful when you subtract away. You've got double negatives. There's a lot of minus signs there. Please be careful in your math. And again, if you're ever not sure, plug that into your graphing calculator and check your work. So that determinant is 24. That is going to come in handy here when we go ahead and try to find x and y. So if we look back at the top box here, to find x, we need that determinant that we found of this A matrix, this coefficient matrix. To find x, we are simply going to take the original matrix we had, replace the x, the values that were associated with the x. So the A and the C are directly associated with the x. We are going to replace them with the constants that were after the equal sign. So in short, if I want to find x, I'm going to replace what was stuck to the x with the stuff after the equal sign. That's the less technical way to explain it. So if I look at the example underneath here, my x values were the 6 and the negative 3. I am going to replace it. Instead of having 6 and negative 3, I'm going to take the two numbers after the equal sign, negative 16 and 16. The second column is going to stay put. And again, this is what's going to allow us to find the x value. So I'm going to go ahead and label that. That is going to be divided by the determinant we found of our coefficient matrix, which was 24. So again, you can do this by hand, you can do this in your calculator, but you're still doing the same determinant math. So I'm going to shorten it up a little bit here just so I don't have as much to write. Negative 16 times 5 will go together first. That's negative 80. Negative 2 and 16 make negative 32, so it'll be minus negative 32. All over 24. Basic PEMDAS, that turns the top into negative 48 over 24, which turns into negative 2 as my x value. So now that we found the solution for x, we're going to go ahead and use Cramer's rule to find the y value. So to find the y value, it's kind of the same idea as finding x. I'm going to take the original matrix, and if I want to find y, I'm going to replace the two values on the right. Those were the ones associated with the y, and replace them with the constants at the end. So again, if I want to find y, replace the values on the right with the stuff after the equal sign. Okay? Because again, the stuff on the right, the b and the d from the original, were associated with the y's. We replace them with the constants that were after the equal sign. So here's what it'll look like. So move some stuff up here. Let's go ahead and find that y value. So again, take that original matrix. This time we're going to keep the x column the same, the 6 and the negative 3. The y column, since I'm finding y, that's going to get replaced. And again, we're going to divide that by our original answer, our original coefficient determinant of 24. Once again, same two steps. Multiply the diagonal from the left, you get 96. Subtracted by the diagonal from the right, it's 48. Simplify it down, you get a positive 48 over 24, which is equal to 2. Your final answer, negative 2, 2. Now, you might be looking at this going, I could have solved this using elimination, I could have solved using substitution, and it might have been faster, which may be the case, okay? This is, though, another way that you can go ahead and solve for it. That is the point of matrices. Matrices allow you to solve for x and y solutions, and if you get further along in math, you'll see problems that have 3 variables. Matrices are what allow you to do that with some relative ease, and again, you can always use your calculator to shorten up some of these steps. The key is, though, when you write this out, you need to make sure that you write out the matrices as you see here, so that way you know exactly what numbers you need to type into the calculator. So, that is how you use Cramer's rule to solve for a system of equations. Again, the short version, find the determinant of your coefficients. To find your x, replace the x column with the numbers after the equal sign. Find their determinants and divide by your answer. To find the y value, replace the y column of your original matrix with the numbers after the equal sign. Divide by the original answer, and you'll get yourself your x and your y values.